10 exactly at 10:50. So now we have done till I think set operations. So we have done till set operations. Now we will move on forward with the help of say joins, natural join and other things. So natural join I think is already covered in your lab, but still I'll give you some of the basics of the natural join part. So natural join will keep that in mind, will always work in a case when you join when the row is equal, when the one column is equal. Just wait a second. I'll try to see. So Cartesian product is already covered. So Cartesian product is nothing. The cross product is just a multiplication of two tables. You already know that. So just for the sake of comparison between the Cartesian product as well as the join, I'm using a Cartesian example. Okay. So cross product you already know and it is already covered. So just for comparison purposes and summary purposes, I'm using it. Okay. So it is again, suppose A, B and C column is already given to you, and then there is something called D. So there is something called 1AB, 2CD. Suppose there is something called ABC. Okay. So now when you are performing this is R relation and this is a S relation. When you are performing a cross product, it's very simply straightforward. Okay. So what you do, you combine these two particular things, A, B, C, D, E. Now the degree here will become 4. Okay. So degree here will become 5. Sorry. Okay. So degree means that the number of columns. And what is cardinality means? Cardinality means the number of tuples. Keep that in mind. Okay. So it will be 1A. Again, you can go it like this or differently as well. So it is 1, 2, 3, 4, 5, 6. It will be 6. So I'll again write 1A, B, C, D, 3, E, F, 1C, 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 2D, 2D. So you already know that how to perform this. I'm just what you say. I'm just telling you that main points here. So the main point in this one is the what is the cardinality of R. Suppose the cardinality of R is the means the number of rows. Number of rows in R. Suppose it is given as M, and the number of rows in S is given as N. So this is the cardinality symbol. Cardinality means the number of tuples. Okay. So when you are doing a cross product of R into S, the cardinality of both will be M into N. Okay, so it is maximum as well as minimum. So minimum you will get this number of rows, and maximum you will also get this number of rows. You cannot get more than that. Okay, so 3 into, there was 3 in relation R and 2 in relation S, and you will get 6 entries here. So 1, 2, 3, 4, 5, 6. Okay. So maximum is it is 6 and minimum it's also 6. Now it's the now what happens to the degree? Okay. So degree of R into S will be whatever is the degree of R plus degree of S. So this is a plus. Okay, so degree of R, the number of columns. The number of columns in R is 3. Number of columns in S is 2. So 3 plus 2 will be 5. So keep that in mind. Cross product, I'm just what you say summarizing everything. Okay, so keep that in mind. The degree and cardinality is different things. So cardinality is the number of total tuples or total rows that are present in a table, and cardinality is nothing. Cardinality is number of tuples, and degree is the number of columns. Okay. So now when you want to apply a join here, whenever you want to apply a join, what you do, you just write something like that. Join is a combination of two statements. Okay. So suppose you write select A equal to D, A equal to D, and you multiply the table R into S. So same table. Okay. So now if I just take this example, I'm just taking the cross multiplication of both of these, placing it here. So where A is equal to D, A is equal to D here and A is equal to D here. Only two particular rows will be filtered out. It will be A, B, C, D, E. It will be 1A, B, 1C, 2C, D. Okay. So you're seeing here we are using the cross product, but with the cross product we are using select operation as well. Okay. So join is a combination of select multiplication followed by a select operation. Okay. So this is referred to as join. Okay. So first we have done the multiplication of two tables, that is R into S, and then we have applied a select operation with the condition. Okay. So whenever there is a select operations, so the number of rows that will be present in the table will depend upon the condition that you are giving. Okay, so now the maximum and minimum will change in this regard. Okay, so just to conclude that we have seen join is a combination of sorry. This particular statement is given as sigma of A into D R cross S, and then it is equivalent to R join S, where A is equal to D. You can write like this. Okay. So now in this particular thing you are writing the condition at the bottom of the join symbol. Okay. So when keep that in mind in place when you are doing R union S, now you can put condition here. Condition here. So condition can be, you can apply condition one and or any operation. There is no problem in that. You can apply and operation or operation. You can apply equivalent comparative operators as well, because this is simple condition of select. Whatever you can do in select condition, you can apply here. Okay. So this is in the case of a join. Now I want to conclude here. Okay. So one more thing to conclude before doing it. There is something called a theta join. Okay. So theta join. There is something called a theta join. So whenever the comparison is in between the attributes, okay, so whenever the comparison is between the attributes, you can call a join a theta join. Okay, suppose if I give you an example here, suppose there is something called R join S, where A is equal to D. Okay, so A is equal to D means that you are comparing the attribute with another attribute. So A is attribute, D is attribute, and you are comparing it. Okay, so this in this case you can call it a theta join, because you are comparing only attributes. Okay, so if you are comparing like this, R where A is greater than equal to 1. Okay, so here you are not comparing it with the attribute, but you are comparing it with the constant. So this will not be referred to as a theta join. So this is not a theta join. Now it can be possible that you are doing like this, uh, where A is equal to D and A is greater than 1. Okay, so in this case also this is not a theta join. So the comparison should be between only attributes, but in this AND condition second part you are comparing it with a constant. So that is again not a part of theta join. Okay, so keep that in mind. Theta join is just a condition that the comparison should be between attributes. If the comparison is not attribute, you cannot call that a theta join. You can simply call it a join. Okay, just for your own sake. Now, to conclude it, that what is the difference between cross product and a join? So I'll again write the statements here. Now I'm writing the statement here is that you are given two relation R and S. The number of columns and number of rows that are available. I'm generalizing everything now. The number of rows that are available here, rows or tuples, suppose tuples or rows that are available here is P, Q. The number of columns or degree that is given in R is given as M and N. Okay. So now check it. Now you will apply what do you say, a cross product. What is the difference between a cross product? What is the difference between a join? Okay. Now the number of attributes in case of a cross product. Number of attributes means number of columns. When you apply a cross product, will be just simply m plus n. Okay. So whatever the column available in R, you add it to the S. That is very simple. Similarly, the in join also you will also get m plus n. There is no problem in that. Now, the only change will be in the number of tuples. Okay, so the number of tuples is in case of a cross product will simply be m into n. Yeah. Okay. Sorry. Tuples is given as rows is given as p and q. Sorry. The number of tuples that is available will be p cross q. That is very simple. Now here is the change here. So it is minimum and maximum, it is available like this, but here because of the select condition, the minimum number of tuples you can get is 0. Because suppose that you are saying that you when you are combining two tables, that is salary and employee, and you are giving the condition that you want to get the name of those employees who have a salary greater than 1 lakh. Okay. So if there is no entry present in, if there is no employee that have a salary greater than 1 lakh, there will be zero entry. Okay. So because when you are joining, everything is dependent upon the condition. So the condition can also be set in such a way that it will not return any kind of a row. It will not return any kind of a tuple there. So it can happen. Okay. So that is why minimum number of tuples that you can get is 0, and maximum is always m cross, sorry, p cross. Maximum is always there is no problem. Just wait for 1 minute. Wait for 1 minute. Okay, so keep that in mind. In case of a join, the minimum number of combination when you are getting in case of minimum number of couples that you can get is 0, and the maximum can you always get. The best case can always be p cross q, because there may be any condition that is satisfying all the there may be some condition. Suppose that you say that the salary is greater than 1 rupee. Okay, so every particular employee will have a salary greater than 1 rupee. So you will get all the entries there. So that is also possible. Okay. So now the natural join I think we will discuss after some time, but I'm more concerned with the one operator that is left, that is division operator. Okay. So division is a bit different operator that you have seen there. So just let you know. So division is a very different operator that you may have seen. Okay, so the implementation is also a bit different than you may have seen. It's a little bit complicated, but it's very easy to understand. Okay, so there is a shorter way and there is a longer way to do division. So I have always prefer the longer way because with the longer way you are given the steps. Okay, there are 3 steps to do division. Either you can do it directly also, so I'll also tell you directly how to do it, and I'll also tell you the steps. Okay, so because when the number of columns increase in division, there will be a little bit of difficulty to understand or to implement how division actually works. Okay, so suppose there is a column, suppose there is a relation R that is given to you, and in this particular relation you are given with only 2 columns. Okay, the 2 columns are set in such a way like A1, A2, A1, A2, and then A1. Okay, another because the division have to be. Okay, so the division should have to be between 2 columns because division is a binary operator. Okay. So when you divide R union S, first step you have to perform on the attributes only. On the attributes, you cannot perform it on the table. Keep that in mind. Is the set difference. Okay, set difference of R minus S. R minus S on the attributes only. Because if you apply it on the table, the condition is not satisfied. So what is the condition here? That both of the table have to be on have to have the same degree, and both of them will have the same data type. Okay, so the first condition is not satisfied. So you cannot apply. Keep that in mind. You are not applying uh, the minus or set difference operation on what you say on the uh, tables, but you are applying this on the what you say header part. Okay, so I'm telling about header. So header is a comma b minus a, that. Okay. So when you subtract it, you will get b. Okay. So it means that your answer will be in terms of b. Your answer will be in terms of b. I do not know the answer now, but I know that the answer will be resulted in the b1. Okay. So it is just when you are dividing a with a, the resulting part will be b. So I'm writing it as b. Okay. So now check here. It's very confusing. Now just listen to me carefully for the next 2 minutes. That you will easily understand the division operator. Okay. So now check in the S relation. The S relation have an entry of A1 and A2. Now, now check corresponding entry, corresponding entries. Uh, Now check the entries. Okay, so I'll write it because it's a little bit confusing step. So you have to check the entries corresponding to A1, A2, A1, A2 in relation R. Okay. So now check corresponding to A1, A2, which is the entry that is common. It has to be common. So both of this A1 and A2, there is one common entry that is B1. So you can include B1 in the table. Directly, this is the answer. Now check again B A1, A2. There is another entry that is common to both A1 and A2. That is B2. You can directly write B2. Now check again. For A1, the entry available is B3, but for A2, B3 is not available. So you cannot write B3 here. Okay. So again, very simple step. First, you do subtraction to get the resultant header. Okay, how you do, simply minus attribute header ab minus a, you will get the resultant header. Okay, so now what you do, simply you check the second table, the entries of the second table. Now you check the corresponding entries, like in the table I have checked that there is some two entries here, that is a1 a2. a1 a2 will always be available in the same header name, okay. So go back to the original table and check the corresponding elements uh, to the entries that is present in the S relation. Okay, so A1, A2 here, I go back to the original table and I check the corresponding entries to A1, A2. Okay, the corresponding entries to A1 and A2 is common here. It has to be common. So common here, that is B1. So I have included B1 in the answer. Again, I have checked A1, A2, and again there is a corresponding entry that is common here, that is B2. I have again included B2. And in A1 there is one entry, that is B3, but for A2 B3 is not there present in the table, so you cannot include B3 in the answer. It's as simple as that. Okay, so division operator, if you want to solve it directly, you can perform it like that, but it is not recommended, because when the number of rows, when the number of columns increase, the division becomes a very difficult. Okay, so how can you do it? It's another way to implement it. So division can be implemented with the help of basic operations. Okay, so division with basic operations. Basic operations mean that we have already done, like multiplication, cross product, minus, and again. So now check here. The first operation that you have to generate is a temporary table T1, and that T1 again will, you have to select the use of pi operator. Pi r minus s is, again we are minusing the header part. Okay, so and then you write from relation r. Okay, so everything is performed on relation r. So what I'll do, I'll just copy and paste the relation here. And the s was very simple, a1 a2, yeah, but there is no use of s right now. Okay, so because we have to select anything on r. Again, you are seeing the pi here, so I'm solving this particular thing, that what is r minus s. R minus s is again a set difference that is performed on the header part only. Keep that in mind. R minus s is concerned for the header part or the attribute part, that is ab. So you write ab minus b a, you will get here b. Okay, so actually this particular statement can be reduced to pi of b r. So you just have to get the projection of the column B from relation R. So what you get? This is one. Okay. So projection means that there will be no duplication in this one. So the answer for T1 will be, you will get B here, and what is it? B1, B2, B3. Okay. So you cannot write B1, B1, B2, B2, B3, because in projection, if you remember, duplication is not allowed. Okay. So because it is based on set theory, so the answer will be, for the first step, will be this. As simple, very simple. Till here, if anybody has any doubt, let me know.
No, sir.
Yes, yes, please. Okay. Now, the second step is again a little bit, this is the only step that is complicated here. Again, it will be T2, then it will be again the same thing, R minus S. Again, R minus S actually means B here, because we have already performed R minus S. Again, it is on header part. Okay. So now only this step is a little bit difficult, that is S into T1. T1 is the table that we have obtained in the previous step, and then you have to subtract it from R. Now this is a total subtraction. Total subtraction means that the subtraction is between the tables, the relations. Okay. So now first you, what you do, you take the S part. S part is very simple. It is I think A1 and A2. Okay, so S part is A1, A2. So I'm just revising this relation as pi of b, because r minus s is b we already know, and I'm writing everything similarly. So now what is S? S is this one. What is T1? T1 is B1, B2, B3. Okay, you have to cross multiply it. Okay, so you have to cross multiply it. B1, A2, B1, A2, A1, A2. So it will be B1, B1, B2, B2, B3. So this is your main relation you got. Now this is the relation you got from S into T1. Now you have to subtract mine R from it. So what is R here? So I'm just copy and pasting R again. R is very simple. So the division and multiplication and this part is very simple. Okay. So now you check, you just have to subtract it. Okay, so both of them has the same degree. S minus R have the same degree of two columns and they have the same what do you say data type also. Okay, there is no problem now. You can easily subtract it. So A1 B1 is present here, so you can subtract it from here. A2 B1 is also there. A1 B2 is also there. A2 B2 is also there. A1 B3 is also there. Okay, so the only common the part is remaining here after subtraction is A2 B3, that is of A and B. Okay, so this is part that is remaining. So this is done. So till here I got this part. Now you have to project B column. So project B column will be the T2 is B3. Okay, so till here if anybody has any doubt. Okay, so you will after solving it, what we have done is S into T1 minus R. So after solving it, we got A to B3. So this particular step we have performed. Till here, the answer is this. After that, you have to get the project of B. In the end, you have to get the projection of B, that is B column. So I only get B, B3. The third step is very simple. You just have to minus T1 minus T2. So this will be your answer table. It will be given as T1 minus T2. So what is T1? T1 is I think B1, B2, B3. This is the T1 that you got in the first step. And whatever you got in the second step, you just have to subtract it. Again, they can be subtracted because they have the same degree as well as they have the same uh, data type. Okay. So what you got T2, T2 is this one. So when you subtract it, it will be you have to subtract B3. So the answer will be B, B1, B2. Okay. So the same answer you got in the first step that you can easily do. Okay. So this what particular steps, these three steps are preferred because what happens in that when you are doing a division, the number of columns can increase. Okay. So when the number of columns get increased, so it is very difficult to understand how to perform a division by using a shortcut method. Okay. The shortcut method is only applicable when there are only two columns. Okay. So when the columns increase, you may be seeing difficulty in understanding how to perform a division. But in this case, if you go with the basic operation, it will be very easy to understand how to perform a division part. Okay. So these three steps. Now you're seeing here what we have done by in the division part also we have used the operation this cross product and then there we have used another operation that is set difference. Okay. So till here if anybody has any doubt let me know. Okay, just wait a second. This is your division operator. It's a bit different than you have expected, but most of the time what will happen, I'll show you that. But again, the shortcut is pretty easy too. You just have to see that if you are dividing the table, suppose there is a first table and second table. The first table and second table. You have to check the contents of the second table, and then you have to match the contents of the second table with the first. Okay, so what it means is that suppose the contents in the table is in the second table is A1 and A2. You have to make sure that that which particular element is common to A1 and A2 in the table path. If for if you find any element that is common to A1 and A2, you directly write that particular element in the answer. So it's very simple. It's a very simple technique. You can do that also. So this is just my observation that I've seen that you can do that. But actually, it is performed like this one. Okay, so the actual performation and actual how do you perform, it is followed by these particularly three basic operations. Okay, so now till now we have seen many operations now with the help of join. So now why what do I have to tell you is that there is something called a complete set. Now, what is the concept of a complete set is that whenever you are applying operations that are unique and that cannot be implemented with the help of any underlying operations, then you can call that operation a complete set. Okay, so suppose the example of a complete set will be select, project, union, set difference, and I think a cross product. Okay, so all of these operations you cannot implement this operation with the help of any other operation. So I can call these operation a complete set because they are not dependent on any other operation. Okay, but there are operations that are dependent on the complete set operations. Okay, so the operations like join, division, and then intersection. So these operations can be implemented with the help of already present operator. Okay, so join is implemented with the help of a select followed by a multiplication. You are seeing here it is following the combination from the complete set. Okay, similarly this division part will follow a project operation, multiply operation, and minus operation. Again, the intersection is again implemented with the help of a minus operation. Okay, so you already know it. So we're seeing here we cannot call this operation, these particularly three operations, they are or not a complete set. Complete set are only those operations that are not dependent on any other operations. Okay, so select cannot be implemented with the help of a minus. Select cannot be implemented with the help of a project, not with the help of a union or with the help of a multiplication. Okay, so keep that in mind. It's a very important concept. You may have studied this particular thing in digital electronics also. So that was, I think, this particular concept is referred to as completeness. Okay, so completeness of an operator in digital electronics. Okay, similarly here it is referred to as a complete set. Okay, so again I am saying that the concept that you see across computer science will be repeated in other subjects also. So that is why CS is one of the easiest branch that you can see. So CS just does not mean computer science; it just means common sense. Okay. So now coming to the join part again. So joins operation, natural join you already know. So I'll just show you natural join. Natural join example is already given here. It's already covered in your lab part as well. So I'm just giving you example. Natural join is a combination of this. So natural join is implemented with the help if there is a common attribute with there is one common attribute with inside when you are doing a natural join, there has to have one particular common attribute in the table. Okay, so if there is no common attribute in the table, it will be referred to as a cross product. Okay, so keep that in mind. Okay, whenever you are performing a natural join, there has to be one common attribute uh, between two tables. Okay, so you're seeing here there is one common attribute between two tables. Okay, so first you do cross multi product. Just wait a second. Hello. Yes, yes. So now if you're seeing here, first you have to do a cross product. Okay, so cross product means that you are multiplying it. Again, you will get 3 into 6 entries. Sorry, 3 into 2. That will be your 6 entries or 6 number of tuples you will get. After getting 6 number of tuples, what you do? You have to see that where C is equal to C. So where 2 is equal to 2, you will filter out only that particular column. Where 4 is equal to 4, there is no 4 is equal to 4. So only one particular column or one particular row will be filtered out. That will be 2 1 2 and 2 6. Okay, you can check it that the natural join will work like this. Okay, so A B R into C and S into D means that they are giving the same column. I think it should be S into C. Okay, so they are giving because the column name is same here, so they are identifying it with the help of a relation name. Okay, table name, that is R dot C and S dot C. Okay, you're seeing here only this particular column is called. Okay, so that is how your natural join works. For natural join, uh, if your column is not equivalent, suppose you are combining the table like ABC and then D. Okay, so in these two columns, you are not in these two tables, you are not finding any attribute that is common to each other. Okay, so it will simply becomes a cross product. Okay, it will simply become a cross product because there is no particularly column that is equivalent to each other. Okay, so just wait a second. Okay, so keep that in mind. Firstly, if this first step will be to rename the other table column. Okay, suppose when you are doing a natural join, there is no common column. So first step will be to rename this column as A, B, or C. Okay, so if you are not again doing this, you are just writing a natural join between R and S, then it will just perform a Cartesian product. It will not do anything because there is no common column there. Okay, so this is one exception which you have to keep in mind. Okay. So now moving on further with the because we already know the number of joins here. The total join we have studied is outer join, full outer join, left outer join, right outer join, and then there is simple join. Okay, so I'll just take simple examples. I just want to conclude here. Okay, so I just want to conclude uh, here by taking the relation R and S. Simple example only of two columns, not more than that. Suppose one A, two C is there, and then there is a S table, there is C and D, there is one B, and 3D is there. Okay. So when you are performing a join operation, simple join operation which will be R join S, and the A is equal to C. I am giving the condition of A is equal to C. So what is the output? You multiply it. Where A is equal to C, A is equal to C only in this case. So the answer will be A, B, C, D, 1A and 1B. You already know it, so I think you have performed this particular join many times, many times. Okay. So now the left outer join. So this is simple join. Left outer join is denoted differently. Left outer join. It is denoted as it is extended towards left side. Okay. So what it means is that you first take the simple join. Condition is similar. A is equal to C. So first take the join condition that you got, the common part A, B, C, D. 1A, and then you take those part that is not included from the left hand side table. So 1A is already included in the table, 2C is not included, so include 2C and write null and null here. Okay. Similarly, you obtain right outer join, very simple. The symbol for this will be this, and what you do in this part, you again take the common part first. A B C D, common part is 1A 1B. Now
सर
check
क्विज
from
का
the
पासवर्ड दे दीजिए, अब शुरू होने वाला है
what?
सर। क्विज का पासवर्ड
Oh,
सर 10-15
sorry.
से होगा।
Yeah, I'll just share the quiz password.